Okay, I think I found a solution. This is difficult because remember, so I'm trying to create a rule based on these graphs. Like I look at these raw, this is the raw data, and when it goes from 63 down to 20, I know that's not real. And I'm trying to make a rule with these numbers, like, okay, every time the the raw value goes below the average of, you know, that frame and the 30 frames around it or whatever, then it will be considered to be a messed up frame and it will throw it out. But that wouldn't happen until you get to like here or even here. So you'd still have these frames here polluting your data set. So I think the answer is actually to look at the change in eyes and pupil size over time. So how would we do that? We would go into our little scrap Excel sheet here, and we would say equals. We would look at the pupil size, and we would subtract that pupil size from the one before. And lo and behold, we get a velocity of -1. Or I guess maybe you could say, velocity has a direction, right? Anyway, it's a change in size of -1 units per frame here. And usually you're going to find, if you go all around here, we'll copy it down. Look at that. That it's always 0 or -1 or 1. I think it might even be, maybe we could find a place where it's 2. Yeah, look at this. If we paste up, it goes from 62 to 64, so it's 2. Okay, but never is it 13 or 27 unless it's one of the messed up frames. So this is our answer. So what we're going to do is say if the change in pupil size is something like, say, greater than 5, boom, you're out. Boom, you're out if it's greater than 5 in one frame. Okay? And what we'll do is, I don't know if that's right or not. I mean, what you could do is you could make it relative to the subject or something. The standard deviation. Well, yeah, okay, let's see. So if we calculate the standard deviation of those, we get 5. So yeah. I don't know if, let's see. What if we took a larger sample though? If we took like all of trial 1. Good night. It's a lot of frames. I'm trusting that, okay, it's eventually going to end. So yeah, so when this goes from 1, column I there goes from 1 to 0, that's the end of trial 1. So what I'll do now is, that's the changes, the change in pupil size from that frame to the prior frame. If I take the average of those, the average is probably going to be 0, yeah. But the standard deviation is 1.6. So I wonder what we might do is say, if we calculated the standard deviation across all the subject's pupil data or something like that, and we said equals that times 3, that gives us 5, which was my kind of gut. So yeah, anything that's more than 3 standard deviations from the average change, from 0, in terms of the velocity of pupil sizes, will be a time we'll throw out that trial. So let's look at this. I'm going to add one more thing to our graph here. Pupe change equals, and I'm going to say hold on plot pupe change. All right, now we have this thing that's like waka waka. It goes to here, right where, oopsie, right where this thing gets messed up is right where the pupil change scoots down to something that's -3 there. So that one might be included by accident. But here, this one, this frame is out, and this frame is out. we could perhaps compute the absolute value of it. And anything above a certain value would be out. Let me just try that real quick. We'll do that instead, see if that looks better. Equals absolute value of that. Yeah, here it is. The only problem is here, since it was for 2 in a row, it was at 20. The velocity there was 0. And so that frame would actually be included based on our little algorithm. Shoot. I will pause and think for a while.